Um, yes, I'll get started on talking about the open source serverless cloud certificate authority. Uh, so yeah, I'm going to begin by just chatting through why we developed a private cloud CA and didn't just use something that was off the shelf. I'm then going to move on to describe the architecture that we used for this. I'll talk about the some of the features and options that are available with the certificate authority, and describe some of the different methods of issuing certificates and publishing certificate revocation lists. I'll go through some example use cases. So what might you actually use this for? What's the point? And for one of those use cases, I'm going to give a live demo. I'll then be talking about some of the security considerations should you decide to implement something like this yourself, and briefly mention some of the things that might be coming up, and wrap up with links and contact details if you want to get in touch. So that's the plan. I'll get on with it. At Q Solution, we provide managed services to the UK government, mostly software as a service, SaaS services. And we provide all of those from the cloud and mostly using AWS, Amazon Web Services. And for several of our SaaS services, we offer services which are very much for a closed community of government departments and government bodies and organizations. And as you might expect, security of these communication systems is paramount. So historically, these secure communications have all been done via private networking. However, there's a desire to move to internet-based methods of connecting between for these government systems and messages. So we need to do that in a secure way, and the way that we've chosen to do that is with client certificate authentication. And so for that, we need a private certificate authority so that we can completely control what devices and users we issue those certificates to, so we can be confident about the integrity of the secure community. So as you might expect, we began by looking at what AWS services there were for this. And we found that the AWS did offer a service, or does offer a service, called Private CA. It's a very good service and has a wide set of features and would have actually met our needs. However, the cost of the service is $400 per month per certificate authority, and on top of that, there's a 75-cent per certificate charge. Well, that might not sound so much. However, we deploy all of our cloud infrastructure using continuous integration and continuous deployment pipelines. So we have multiple environments, development, staging, production, and so on. And we want separation of trust boundaries between these environments. So we want to have a certificate authority for each of those. We also have more than one system, which again require different trust boundaries. And when we added all this up, it was looking at something like $70,000 per year for 7 environments, given that we wanted to have a root CA and issuing CA pair in each environment. And that was an excessive cost for us. So that was the main motivation. And this is what we built and developed. So what we came up with was we made use of serverless functions. So we have serverless functions, Lambda functions, which are used for different tasks within the certificate authority. So creating the root certificate authority, creating the issuing certificate authority, publishing certificate revocation lists, and publishing the end user and end device certificates. So we have collection of Lambda functions. We orchestrate those using using step function, and we run those at a minimum of once per day via EventBridge. We publish a certificate revocation list to S3, and optionally present that to make that publicly available through CloudFront. The private keys of the certificate authorities themselves are held within AWS Key Management Service, KMS. We publish details of the certificates to a DynamoDB table. And finally, we issue details of certain categories of certificates to Simple Notification Service, SNS, so that they can be picked up by EventBridge or simple email service for other, for management tasks. So the cost of the system, typically for this environment, it's around $4 per month. It might be more than that with excessive use in a very, large DynamoDB database, but you can see it achieved our aim of being very substantially lower cost than the AWS service, and that is for both the root CA and issuing CA pair. So that's our approach. Some of the features of the open source Cloud CA. We store private keys for the certificate authority within AWS Key Management Service, and they're generated there as well, so they never leave and can't be exported. KMS was certified by AWS a couple of years ago to the standard, the FIPS 140 to level 3 standard, which is the de facto federal standard for hardware protection of cryptographic material. We recommend the use of elliptic curve algorithms for the certificate authorities. There is a choice, but the elliptic curve is the default rather than RSA. Certificate revocation lists are published once per day by default, and optionally can be made public through CloudFront, in which case a CRL distribution point, or CDP, and an authority information access, or AIA point, are included in the certificate. The AIA point being where you can download the CA certificates from, the CDP being the URL that you can download the certificate revocation list from. And some applications require those to be present. Access control for the certificate authority is entirely implemented via AWS Identity and Access Management, as you might expect, being in AWS. Monitoring and logging is via CloudTrail and CloudWatch. So CloudTrail for events such as the certificate authority signing a new certificate. CloudWatch for more application level events that are going on within the Lambda functions. The certificates are issued entirely via automation, and the whole solution is 100% serverless. So what you're seeing here is just a graphic that's of the step function that orchestrates the Lambda function. So there are some of the main features of the certificate authority. So we sort of realized that if we were having this sort of issue with the pricing of AWS Private CA, then the chances are quite a lot of other organizations would be as well. So we decided to make the solution open source. And part of the motivation for that was to get the benefit of contributions from the community and the scrutiny that publishing this sort of material as an open source repository then results in. So all of the documentation is at serverlessca.com. So that's where the documentation is and links to everything. So that's a very good place to start. And there is a getting started guide. The actual GitHub repository is shown here, github.com, serverless-ca, terraform-aws-ca. And the reason that it has that particular format for the naming of the repository is because we publish as a Terraform module. And that means that the solution is extremely straightforward for organizations to incorporate to their infrastructure. It's very, very easy to just call a public Terraform module. And also very straightforward to update, simply changing a version number. So that's the way that we've implemented it. So a couple more aspects of the certificate authority. We have a couple of different options for issuing certificates. We have two approaches. The first is an Lambda directly invoking the Lambda function which issues end device certificates. The second option is a GitOps option, which is more particularly suited to where you have third parties. There might be creating a certificate signing request, and then that needs to be approved. And that's approved by means of submitting via a pull request and approving the PR. Once it's merged into the correct file and folder, which is as part of the repository, which is calling the Terraform module, then when the step function is when the step function is executed, then those certificates are automatically issued. So both approaches are automated. There's an approval set in the GitOps option as part of the pull request process. Here's an image of the an example certificate revocation list on the left. And on the right, there is you'll see that there's a serial number of a certificate that's been revoked. So I've talked quite a lot about all the different options and what it's designed for and so on, but what could this actually be used for? Well, it's standards based, so you can really use it for anything that makes use of certificates, but some particular examples are shown here. So firstly, we have API gateway. So I'll be talking more about that in a minute because that's what I'm going to demonstrate to you. A next use case is ECS, Elastic Container Service. So here, certificates can be requested and automatically issued to ECS tasks and then be used for secure communication between one ECS task, which includes a container or multiple containers, to another ECS task. Similar sort of benefit is there for EKS, Elastic Kubernetes Service, where certificates are often used within a service mesh to ensure that all the intrapod communications are TLS, transport layer security, encrypted. Another great application for this is Internet of Things. So you might have, for example, a vehicle which then connects to a central system from the manufacturer and reports telemetry and whether there's a need for a service update or a fault. These communications take place regularly, but it's extremely important, obviously, that only the authorized vehicles and devices can actually connect and send updates or receive firmware updates. So that can be done with a certificate and key on the end device. and authentication to IoT Core for onward processing of that data. Amazon Workspaces is another great application for certificate authority, where so Amazon Workspaces is a sort of VDI-like solution for workers, for productivity or development applications for end users. And with certificate authentication, you can require that the device that connects to Amazon Workspaces has a particular machine certificate. Another application within AWS is Application Load Balancer. So about a year ago, or a bit less than a year ago, AWS announced mutual TLS for ALB. And that can be a great solution if you have a closed community of users who you want to allow access to a particular web application on the public internet. Another interesting AWS service is IAM Roles Anywhere. So this is a solution which is really designed for servers that are completely outside of AWS to be able to connect in to an AWS environment and have permissions within an AWS environment for certain tasks. So IAM Roles Anywhere effectively replaces the need for a user identity for that machine and an access key and secret key. So it replaces all of that with a client certificate and corresponding private key. So that's IAM Roles Anywhere. So there are quite a few examples of different AWS services which are have options for client certificate authentication. However, because this is standards-based, it doesn't have to be AWS. The service could, while the certificate authority is implemented in AWS, it could support an application that's on-premise or in Microsoft Azure or in Google Cloud Platform. And interestingly, just I think it was actually at the weekend, or certainly the last few days, maybe the end of last week, Google Cloud actually announced that they now have an option for identity authentication to Google Cloud using client certificates instead of instead of the current approaches that are used with service accounts or human users. So there are some of the private CA use cases, and for several of these, I've written up detailed sort of blog posts showing step-by-step guide to how to actually do that integration with our private cloud open source CA. In particular for API Gateway, ALB, IAM Roles Anywhere, and the links for all of those blog posts, which are on Medium, can be found at serverlessca.com and are also present at the towards the end of the also present towards at the end of this talk. Okay, so let's move on. Now, I mentioned that I was going to go into more detail and demonstrate the API Gateway, mTLS, with the open source cloud CA. So this is what I'll be showing you. So we have an API Gateway. In this case, we're creating a response using a backend Lambda function, but it could equally well be a Kubernetes cluster or ECS cluster or EC2 or whatever. And what we're doing is we're saying that we're going to trust a client certificate which connects from a server outside of AWS, and we're going to trust that provided that client certificate is published, is issued by the issuing CA and root CA that we trust. We're going to simulate the server that's connecting in with my laptop. So that's what we're going to take a look at. So let's do it. Okay, so I'm going to let me begin. Hold on, so let me just begin with yeah, so first of all, I'm just going to show you the documentation site. So this is the site I mentioned, serverlessca.com. So all of the links to the GitHub repository and to the blog posts, etc., are all available here at serverlessca.com, as well as a getting started guide, as you might expect. So that's the documentation. The actual GitHub repository, as I mentioned, is shown here. So if you want to support us and you find this interesting or think this is something that we should, you want to support, please, do go ahead and give it a star. That would be great. Maybe we can get it above 100. So thank you. Yes, and then also, as I mentioned, we do have a Terraform module available for download, an incorporation to your infrastructure as code using Terraform. So pleased to see we've got over 2,000 downloads so far, which is good. So that's yeah, some of the documentation and some of the sites I was talking about earlier. Let's just have a look first at the certificate authority. So this is the certificate authority which I'll be using for this demonstration. So first of all, if we go to Lambda, you'll see all the different Lambda functions that I mentioned. The Lambda functions are created using Python and the Python cryptography module. And as I mentioned, these are orchestrated using step functions. So if we go to step functions and start a new execution, yes, we'll see that the Lambda functions are being run. So first of all, we're checking that the certificate authority, the root CA exists. In this case, it does, so it won't try and create a new one. Then we're publishing a new certificate revocation list. This is actually publicly available. Then in this case, checking that the issuing CA is already there, publishing an issuing CA CRL. And after that, it will check whether there's any new GitOps certificates which are due to be require issuing. And if there are, then it'll issue certificates for those new GitOps certificates. So that's what runs once a day. Let's just have a quick look at KMS. And within KMS, you'll see that we have a the actual encryption, the actual asymmetric keys. So for example, for the root CA, this is the asymmetric key. It's a, in this case, this is all configurable, but it's elliptic curve, SHA-384 we selected. And the public key is shown here. It looks quite short because it's elliptic curve, so a lot shorter than the RSA equivalent. And the private key we never see because that's just held within hardware by AWS on our behalf. So that's the what I've just shown you is the certificate authority. So for security reasons, it's good practice to have a separate account for the certificate authority and not to put it in the same AWS account as the application or system that relies on it. So this is a separate AWS account now where we have the API gateway. So here's the API gateway. You can see that we have an integration present with a Lambda function. And if we look at the custom domain names, I've given this a custom domain name of service.certs.cloud-ca.com. And what we've configured is a trust store, which contains a bundle of the root CA and issuing CA certificates that it is supposed to trust. So that's what we have in place. So now let's just have a little look at that. So if I open up my terminal and try and get to that that API gateway. So you'll see here that the connection was reset by a peer. So I've failed to connect. And that's simply because I didn't use the certificate. So just wanted to show you that, if you don't have a certificate, you can't get to it. So now I'm going to specify a client certificate and key, which is being issued by the correct certificate authority that's in the trust store. So here we are. We've successfully got a response showing that the certificate authentication does work. And if I wanted to see that in a more graphical way, I could use a application like Postman to get the response that looks a bit prettier, but it's the same content. So that is the certificate authentication. So one last thing to see on that is that if we go to CloudWatch, so this is within the AWS account that uses where the API gateway is being configured. We'll go to log groups and look at API gateway access and look at this. So you might think, what's the time? Why is that the time? Well, that's the time where because I'm speaking from London, UK. So that's UTC. So yes, so this is the details of the client certificate that was just used just now to connect. So that's the demonstration. So I will now go back to the PowerPoint and talk a little bit about some of the considerations if you were to implement this sort of solution yourself. So first of all, as I mentioned, it's that the whole integrity of any certificate authority is completely dependent on the security of the private keys of the certificate authority, the CAs themselves. So they're held within KMS and can't be exported. And as I mentioned, KMS has been certified and accredited to FIPS 142 level 3. As I also mentioned, it's good practice to have a dedicated certificate authority account and to have a different CA for each environment or community that needs to rely on that CA. ECDSA, as I said before, was recommended. With any CA service, it's absolutely vital to verify the authenticity of the requesting body, whether that's a human being or or a service. And it's also important to remember that just because we've set up a certificate authority, it doesn't mean that everything's automatically secure. It's not. It's important to protect and be aware of the user and device, the private keys that are being used by the user or device. If these can be protected in hardware, that's ideal. So a trusted platform module or a YubiKey, is great. Otherwise, if that's not possible, then using the operating system's key stores can be a good solution. So, for example, on a MacBook, the operating system private keys are then protected by Apple Keychain. So that can be that sort of solution can work quite well. It's essential to control AWS IAM permissions and really make these least privilege and be very careful as to who has access to what within your certificate authority account. It's important to monitor and log CloudWatch and CloudTrail, look for suspicious events, and to update the certificate authority regularly, which is straightforward to do because of the fact that it's a Terraform provider. So what's coming up next? Well, we're we've already had some great feedback from users. We'd be very happy to have any more feedback from users, any ideas, and we're busy at the moment incorporating the certificate authority to some of our SaaS services, And it may well be that as a result of that, we open source some, complementary technology, that may, help to implement the certificate authority as part of an overall solution. And we very much welcome collaborators. So please collaborate. This is a slide with the links to the documentation. As I mentioned, all of this is available on serverlessca.com, but the links are here in the slides as well. And as I said, there are 4 Medium blog posts which go into a step-by-step guide as to how to actually implement this yourself. So with that, do feel free to get in touch. You can reach me at the Cloud Security Forum. If you're Slack, if you're not a member of that, then you can message me one of the other ways and I'll invite you, or a lot of the organizers are members of the Cloud Security Forum, but that's probably the best way to communicate with me. I do post on LinkedIn and Twitter as well. So just like to say thank you very much to all of you, and thanks to Sans for having me speak.